Before we jump into some crazy college algebra 2 adding rational expressions, today we're just going to take a look and start off with some fractions that you're probably familiar with so we can get an idea of where we need to go for today's lesson. So when we're going to add those two fractions on the left side, you think of 2/3 and maybe you ate 2/3 of a pizza or something like that. And then you took 1/6 of it, and you're like, well, those were different size pizzas or different size slices. So how can we get a common denominator or figure out how the portions are equal so that I can total those up and see how much I actually ate? So the goal is to get a common denominator there. So how do you do that? Well, it would be nice if I could multiply that denominator by 2 over there. But I can't just willy-nilly do whatever I want in math. It's got to balance out on both sides. So fractions will balance out top and bottom. So if I multiply by 2 over 2, I'm technically just multiplying by 1. And what happens when you multiply by 1? It stays the same. So literally, I've kept this problem the same. I just used a fancy version of 1, with that being 2 over 2. So now I have 4/6, and now I have 1/6, and we already did this in class. Common denominators are easy, and there's 5/6. On the right side over here, though, we have different denominators, and 3 doesn't go into 5. There's not a way to turn that into 5. So the next easiest way is to use the 3 and to use the 5 and find a denominator that's going to work for both. So if I use the factors of 3 and 5, that means I could get to 15 would be the lowest common denominator there. Or the least common multiple. So using the 3 and the 5, if 3 doesn't go into 5 and 5 doesn't go into 3, I'm literally just going to share the 5 over on this side, and the 3 over on this side. And remember, when I'm multiplying by 1, I'm technically not even changing the problem at all. Multiplying by 1 will keep it the same. So on the left side, I got 10 over 15. And on the right side, 1 times 3 is 3. 3 over 15, then it becomes easy to do 13 over 15. All right, there's our 2-minute warning for that problem. Let's go ahead and get heavy duty in some algebra 2. So we're adding rational expressions. You can see how these fractions are a lot more difficult. The goal is, can we just focus on the denominators, and is there a way, there might not be, but is there a way to get common denominators? I think I can turn this left one into the right one simply if I double it, right? If I double the 3x and then double the 1, I think that's going to turn into the other fraction. And I can always just try it. If it doesn't work, no worries. So if I double the 3x, that's 6x. And if I double the 1, that's positive 2. You've noticed how I've kept putting this fraction in parentheses. That's kind of a reminder for myself to distribute. And I have common denominator there, so I'm good to go. So I also need to distribute here, so that would give me 2x up top, and then 5x plus 2. Sweet, common denominator. Let's put it all together, and then we just add up. Let me go ahead and change color. 2x and 5x. That's going to give me 7x, and then I've got a plus 2 there, plus 2. We'll talk a little bit more later about should those x's cancel and should those 2's cancel. The answer is no, but for right now, we'll just kind of focus on getting the common denominator and going from there. All right, take a look on the right side. We have an x plus 3. Get recentered there. We have an x plus 3 on each side, but this one has an x minus 3 and this one doesn't. So it's as simple as giving it the x minus 3 and the x minus 3. That is just a fancy version of 1 over there. Cool, now my denominators are x plus 3, x minus 3, and x plus 3, x minus 3. So I have common denominators. Awesome. Up top, I just keep that the same, and then over here, I got to make sure this 2 gets distributed. So that's 2x, and then minus a 6. Now I've got common denominators, so I'm just going to go ahead and put that common denominator right there in my answer and see if I can combine like terms. I have a 9 and then minus 6. That is a positive 3. And then I have negative 5x and positive 2x. So that would give me negative 3x. And there I go. All right, for our last two, we're going to just focus on the same thing. Can we get common denominators? Try to imagine like the lower number. Is there a way to get the lower one into the bigger? Can I multiply this by something on the left side? 5 times x will give me 5x. 5 times 4 gets me 20. Boom. So I can simply just use a 5 to multiply. Now remember, I want a fancy version of 1, so I'm really not changing the problem. And let's go ahead and distribute this 5. That gives me 10x plus 5. That gives me 5x plus 20. Nothing changes on the right side. I see common denominators. Boom. Let's go ahead and put it in our final answer. And then combine like terms. I see 10x plus a 7x, and that is 17x. And I see a 5 and plus a negative 3, so 5 minus 3 is a positive 2. Cool. We go ahead and head to our last one and notice that there is a quadratic over here. There's an x squared. So think about when you get x squared, that means you need x times x. So we should have just finished up factoring, and how can we get this problem? So x squared, made my squiggly a little bit too big there, just my focus. X squared is x times x. And how can I get to the 8? That would be a 2 times a positive 4. And if I think about that, I combine 2 and 4, and that gives me my 6. So I do have common denominators now. And so I will bring this down. And on this side, I have x squared plus 6x plus 8. On this side, I've got x plus 2 and x plus 4, which we just said is the same thing. On the top left, I don't change anything, 4x plus 3, but on the top right, I got to make sure I distribute, and that gives me 5x plus 20. I do have common denominators. They look a little bit different. I'm going to go with the factored form. This might help things simplify in our next levels coming up. But it doesn't matter which of the denominators you chose. They are common. They are the same. You can pick whichever one you would like. And then on top, we are just going to combine like terms. I see a 4x and a 5x, and so that's 9x. And I see a 3 and a 20. That is 23 positive. Cool, there is our lesson on adding rational expressions. We'll talk a little bit more in class and get in more detail, but main goal, how do we get that common denominator? And if you can do that, then it just turns into one of those levels that we already did earlier this year when we had common denominators.